All right, first of all, before we start our notes today, somebody wants to say hello.
Hi, Owen.
There we go. All right, so as I was saying, I'm glad that we have that recorded. Let's lock in. A lot of science words were made up from Latin or from Greek. The word atom was Greek and has two parts. The first part is a. Not. I love that. Do you guys speak Greek? Do you guys speak Greek?
I dibble dabble.
Okay. Abiotic, not living. All right?
Tom is cut.
How did you know that?
We had to do Greek and Latin.
That's correct. Tom is cutting. Dang. All right. Not cutting. So, why would they call an atom? Because they thought, yes, that you couldn't cut an atom, right? In fact, John Dalton is the first famous dead guy of science, of chemistry. He said atoms cannot be split or divided. He said that atoms cannot be split or divided. Is that true?
No.
No, it's not. All right? Because if you split an atom, what do you get? You get a lot of energy, right? You get a lot of heat. And if that splits another atom, that splits another atom, that splits another atom, you either have one of two things: nuclear energy or a nuclear bomb. One of those two depends on the size and the scale, and if you control it. So an atom is the smallest building block or smallest part of an element that keeps the same properties. So I can have an atom of, let's say, carbon. All right? An atom of carbon is still carbon. Is a proton of carbon carbon? No, a proton's a proton, because that is subatomic. That's what we talked about last Wednesday. Yes? Make sense?
Yeah.
Okay, good. I love this balloon. I'm going to leave it here until it
Guess who hung it
deflates.
up right there?
Not Nick.
You did? Did you do it, Alexis? Okay.
No,
well,
she did
thank you.
not.
Okay.
Put it on that drawer.
Anyone know what the charge of an atom is?
Yeah.
What is it? Think back to our candy activity. What was the overall charge of an atom?
What? Nothing.
Neutral. All right? Why is the charge of an atom neutral? Has the same number of, Nigel? Protons equal electrons. The number of protons equal the number of electrons. The next thing we did is I told you to give your atom a charge. Do you guys remember doing that? Lithium with a charge of +1. What did you want to do to give it a charge of +1? You wanted to add a proton. But that did what? Changed its identity, right? What could you do, though?
Take away the electron.
Yes. So an ion is when atoms lose or gain electrons. When they lose or gain electrons. So let's match these up. If an atom loses electrons, what charge does it become? It's the opposite, remember?
Yeah, that's fine.
It becomes positive. Because if I lose negative charge, I then have more protons than electrons. If an atom gains electrons, what charge does it become? Negative. All right, because if I gain electrons, I then have more electrons than protons. More electrons than protons. What about an isotope? We haven't talked about this. Anybody think they know what an isotope is?
I did a flashcard on it, but I forget it.
Okay, some people have done a flashcard on it. Same number of blank. What? Yes. An isotope is the same number of protons, but different number of neutrons. Different number of neutrons. So, in parentheses, what is the only thing changing about an... Well, no, this is going to be later. I'm getting ahead. That's lower down on the paper. I can tell that I made this because I was thinking about it. Can I move my paper down?
Yep.
Gonna move it down, move it down, move it down. Bazinga. All right. Center of protons, different number of electrons. So, what is the charge of an isotope? It's neutral. All right? Because what am I changing?
The number of neutrons.
And what charge do neutrons have?
Nothing.
No charge. They're neutral. What am I changing about an isotope? Go for it.
The mass.
The mass. But the mass changes. Because we know that atomic number, right? Neutrons is mass number minus atomic number. So if I had carbon-13, that is an isotope of carbon. Is that the same as the isotope of carbon on the periodic table? What carbon is on the periodic table? Carbon dash.
6.
No, it's actually carbon-12. On the periodic table, so let's take a look at it. I have carbon-12. So the way this works is it's always the name dash the rounded mass number. The rounded mass number. Name dash the rounded mass number.
What's the rounded mass number?
Well, what's that?
What's it like actually? Isn't that like a word?
Mass number. The rounded mass number is the mass number. Because what we have on here is the average atomic mass. The rounded one is the mass number. Rounded one is the mass number. This next part is really, 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 really important. That's why I put all those stars there. Okay? These next two words are the two most important words in chemistry. Mr. Heller. Yes. No. It's a special type of electrons. Any guesses? What's going on?
I love that song.
Oh.
back there.
Grady.
Is it valence electron?
Ooh, yes. Valence electrons. VALENCE, valence electrons. These are very, very special electrons. And these are electrons that you were either moving or adding in your candy atoms. Where were those electrons in your candy atoms?
Field. Bubble. Orbit.
The electrons found in the blank energy levels or orbitals.
The outside?
Yes, the outermost. Electrons found in the outermost energy levels or orbitals. Valence electrons are the outermost electrons. I'm going to flip my page over. I'll flip my page over. You guys got it? Did you guys see the end of that Commanders Bears game?
I've taken Daniels in fantasy in one of my leagues.
Wow.
Dude, guess what?
Yes.
Malik Neighbors and George Pickens have to combine for 24 points.
Possible. If Neighbors goes off. I just need Pittsburgh. I need Pittsburgh's kicker to not get 24 points, so I feel pretty good about that.
No, he shouldn't. He's a top 50 scorer in vintage.
Boswell's good, but I don't think he's going to score 24 points tonight.
He's done it before. Don't doubt it.
He probably has done it before. Okay, to the back. To the back. So I've got some elements here. You know
Hydrogen.
what? Hydrogen, lithium, sodium, nitrogen, and potassium. Yes.
Oh, right.
Because we had already used S. S was sulfur. So like, what are we gonna make sodium? And they're like, I don't know. Nah.
Can it be just SO?
It's Latin probably. I don't know why we used Na for sodium, but that's just what we chose. Yes. Huh?
Potassium.
P is phosphorus. K is potassium.
Put a
K is
K on it.
potassium. What? Okay. So what I want to do is I want to draw Bohr models for each one of these. So if I was going to draw a Bohr model for hydrogen, how many electrons would go in the first level of hydrogen? 1. How many can the first level hold? 2. How many can the second level hold? 3rd level? 4th level? Good. 2882, 2882, 2882. Why only 1 electron in the first level? Hydrogen only has 1 electron, right? So if I was going to ask you how many valence electrons does hydrogen have, what would you say?
1.
There is 1 valence electron. Because you would agree that that is the outermost electron for hydrogen. Head nod if you agree with me. Okay, let's look at lithium. Lithium. How many electrons would go in the first energy level?
3.
No.
2.
First level can only hold
2.
2. Would I be done?
No.
No. How many total do I need?
3.
3. So how many electrons will go in the second energy level for lithium?
1.
1. So if I asked you, how many valence electrons does lithium have? What would you say?
1.
Also, 1 valence electron. 1 valence electron. So far, we have looked at hydrogen and lithium. Let's look at sodium, number 11. How many electrons in the first level?
2.
2. How many electrons in the second level?
8.
1, 2, 3, 4, 5, 6, 7, 8. Am I done?
No.
No.
We need 1 more.
I need 1 more. Right? 1 more. I need 1 more electron. So how many electrons in this third level?
1.
1. So how many valence electrons would you say sodium has?
1.
Oh, snap. I think we just discovered our first periodic trend. Any guesses? So here I am, over here. I have hydrogen. How many valence electrons? 1. Lithium, how many valence electrons?
1.
Sodium, how many valence electrons?
1.
What group is it in?
1.
Oh. Any guesses of how many valence electrons potassium has?
1.
Rubidium?
1.
Cesium?
1.
Francium?
1.
Yes. All the elements in group 1 only have 1 valence electron. What?
What about like 2, 3, and 4, and 5?
Well, let's look at.
2, 3, and 4.
I'm glad you asked. All right.
And it's in group 15. So it has a bit.
So nitrogen is in group 15.
I don't know if we
Let's draw nitrogen's Bohr model.
have 15.
So nitrogen has how many in the first level? 2. 2. How many total does it need? 7.
7.
Right? Atomic number 7. Agreed? Okay. So how many electrons are going to go in the second level? 5. So second level of nitrogen is going to have 1, 2, 3, 4, 5. It's going to have 5.
Is that how you draw it? Or does it matter? Like with 2?
It doesn't really matter, but it's going to matter more later. It'll matter more later. If you draw like that, it'll help you more in the future. Around the clock like that. If I asked you how many valence electrons nitrogen have, what would you say?
5.
5. You would agree that there's 5 valence electrons. Yes? What is the second number in 15?
5.
5.
Oh.
All right. Any guesses of how many phosphorus has?
5.
Try it. Draw it. See if you're right. Draw phosphorus. See if you are correct.
Yup.
I need to find a periodic table for you guys. It's time. I feel like we've reached that time in our relationship where you guys are ready for it. I'll get them in a second.
Fall.
Because remember, from the notes on the candy day, how many can go in the first level?
2,
Second level?
8,
Third level?
8.
And how many total electrons does phosphorus need?
15.
It needs 15. So, first level has 2. So 1, 2. Second level has 1, 2, 3, 4, 5, 6, 7, 8. Leaving how many for the third level? 2, 3, 4, 5. How many valence electrons does phosphorus have?
5.
5 valence electrons. What group number is phosphorus in? 15. Any guesses of how many valence electrons carbon has?
4.
Silicon.
4.
What about boron?
3.
Chlorine.
7.
Neon.
8.
Ah.
What about 10?
So here in the middle it gets weird. All right. So in the middle it gets weird, and we'll talk about that later. Okay? But group 1 has 1, group 2 has 2, group 13 has 3, 4, 5, 6, 7, 8. What?
Why does it
There's no
3,
9.
4, 5, 6, 7,
Because remember, an orbital can only hold up to 8. What?
Why does it 3, 4, 5, 6, 7, 8?
So I don't want to say why yet, but these are, we have metals, we have non-metals, these are transition metals. So these are a different type of element. They do different things, different chemical properties. Well, hydrogen's not a metal, but hydrogen only has how many valence electrons? 1. So doesn't it kind of make sense to have it over here? Yeah. That's why I put it there. So hydrogen's not a metal, but it makes more sense to put it there. Okay. So we're going to now just talk about the nucleus to finish this up. Yes, Brielle.
Why does
You have to take.
it only has 2?
Okay, another good question. These over here, we're going to find out, are the noble gases. The noble gases are perfect for a reason, and neon is one of those. You'll see why Thursday. Great questions. Guys, I am super passionate about this. If you guys understand what's going on up here, it's like, oh, that's like legit cool, okay? You guys are going to learn so much about this. You're going to love it. Okay. All right, let's talk about the nucleus and then wrap this up. So, nucleus before had a really weird model. Any guesses what the model was called for the nucleus? It was actually like a British dessert, I think.
Scum.
Beans on toast.
The plum pudding model. You were close. The plum pudding model. Plum pudding looked kind of like this. So here's my nucleus, and I had positive, negative, positive, negative, negative, positive, negative, positive, positive, negative. You just kind of draw it, all right? Kind of all over the place. The plum pudding model. But then there was a guy named Ernest Rutherford. Ernest Rutherford. I need to move this up. Can I move it up? Okay. Cool. So, Ernest Rutherford came up with the gold foil experiment. The gold foil experiment, which may lead you to ask a question. What question would you ask?
What is the gold foil experiment?
I would ask what's gold foil, right? First, but you're right. Anyone have a guess of what gold foil is? Yes?
Foil made of gold.
True.
Gold flakes.
And why is it special?
Because Ernest used it.
What? It's what? Did you say Salt Bay? No. Gold is very, very malleable. Gold foil is really, 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 really thin. If you took a Bible, pretty thick book, right? And all of the pages were the thickness of gold metal, of gold foil, the Bible would be 1 page thick. That is how thin gold foil is. So why did Rutherford choose gold foil? Because he thought it was about the width of, guess what he thought it was the width of? An atom. Is it the width of an atom? No, it's still atoms stacked, but it was close. So what he did is he took alpha particles. So these are my alpha particles. Okay? Alpha particles, what you need to know, those have a positive charge. He took alpha particles and he shot them forward. Guess what he shot them into? No. Gold foil. He shot them into gold foil. So, gold foil is really, 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 really thin. So guess what he expected these to do?
Break it.
He expected them to go straight through. And then he had like a reflective thing over here. It was like phosphorus, all right? And if they hit over here, they lit up, right? Whatever they hit on their side, it wouldn't light up. Here's the thing. Some of them went straight through, but the other thing is, some of them went this way. Some of them went this way. Some of them bounced this way. Some of them bounced this way. So there must have been something here in the middle, all right, that these positive particles were bouncing off of, right? So he expected for them to go through. But what actually happened is they bounced. So actually, they bounced everywhere. Some bounced back, some bounced forward, some bounced all over the place. So there must have been something really, really what here in the atom?
Bouncy.
Reflected.
And why is it reflective?
And it reflected
What did it reflect?
particles.
Alpha particle.
And what charge do alpha particles have? And what do charges do? Opposites.
Reflect. Retract.
Opposites attract. Like charges want to repel. So this must have been a really, really what type of charge in order to reflect it? Yeah, really, 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 really positive. Okay, well, what's really, really positive in the middle of an atom?
Nucleus.
The nucleus. So Ernest Rutherford discovered the nucleus, which has a positive charge with the gold foil experiment. You guys would agree that the nucleus only has a positive charge, yes? What's in the nucleus? Protons and neutrons. Question.
If you fired positive particles at a gold atom, wouldn't it hit the electrons first?
Electrons are really, really tiny. That's the thing. And the atom is mostly empty space. So it's possible it could have hit an electron, but electrons have such little weight, it would have just bounced away anyways. Electrons aren't going to stop a proton. These are way more massive than a proton,
Oh, okay.
than an electron. The mass of this is actually like 4. An electron compared to that would be like 1 times 10 to the negative 30th. So these were huge particles compared to electrons. Yes?
Does somebody shoot an alpha particle?
So he had radioactive, I believe it was like uranium, as essentially particles of uranium, and it would just emit radioactive decay off of here. So he got cancer and died.
Wait, actually?
Yeah,
Because of it?
because he didn't know that alpha particles were radioactive. Madame Curie did a lot of things with the X-ray. Well, guess what? Those are radioactive. She was a girl. All right? She died. All right? Because she didn't know that they were radioactive and that those could cause cancer. So a lot of these early scientists discovered some cool things, but it was at a price. It was at a price. RIP. RIP. All right, so I got a little video.